Good morning. This is an installment of the 4C webinar series. Today we'll be talking about Refinery's Fenceline monitoring programs, the AB 1647 Rule 1180, and our featured speaker is Gilad Shpitzer, CEO of Atmosfir Optics. And if you have a question during the webinar, you can click on the little show conversation icon up on the upper right-hand portion of your screen and type the question in.
Hi, Boo Boo. Hi. No.
Hey, Gina. I need to mute Gina.
Sorry.
Okay.
It's talking to
So if you have a question during the webinar, type that question in there. At the end, I'll ask the question. If you would like to have the question right then and there, raise your hand. That's the little smiley face icon with the hand. And then we'll see that and we'll have you jump in and answer and we'll get the question answered at that time. Okay, so without further ado, Gilad, take it away.
Okay, thank you again. And this presentation will be a follow-up for last week's presentation that talked about the technology. So I will go briefly about the introduction. I will just say to the people that didn't attend the last week presentation that Atmosfir Optics is a research and development hardware and software integration company that provides advanced air monitoring services worldwide. We'll skip that part. You can see it in the presentation. The last week presentation. Our product line is actually a defense line system, and we can use an open path instrument. And today we're going to talk about the technology of FTIR and UV DOAS. And because that was what required in the implementation of Rule 1180, and also combination of point monitor for H2S and black carbon. So a few words about the defense line system. It was designed to tell you when unusual emission occur and to identify the emission. It can identify dozens of emissions, dozens of compounds simultaneously. It also designed to tell you where is the source of the emissions so you can go and fix it, and also quantify the emission, not just concentration. So what is the principle of open path system? So what we see in this picture is a monostatic configuration. In this picture, we can see an FTIR, but it's the same goes for UV DOAS. We use two laws. The first law is Beer-Lambert law that says the absorption equal constant multiplied by concentration and the path length. So we know we can measure the path length between our IR source or UV source and the retroreflector, so we know what is the path. We can measure the absorbance, so we can quantify the concentration. The second thing is that each compound absorbs light in different features or spectral signature. What we see on the picture on the left is in red is the spectrum of benzene in IR. And what we see on the right, it's again benzene in blue, benzene in the UV. So the strength of multispectral instrument is simultaneously we can identify multi-compounds. But it also the downside, because we can identify a lot of compounds, a lot of things can go wrong, and we can report a lot of false positive or false negative if we don't know how to do the analysis correctly. And now, because we need to automate it, if we don't have a good enough machine to automate it. That's lead to, I think, one of the best feature of the defense line system, that we don't report numbers. Which every number that we report, you can click on the number and then you got the spectral validation that you know that it's not false positive or not a false negative. What we see in red is the reference spectra from NIST or PNNL. In this particular example is ethylene, and blue it's what we are measured in the field, and now we can be absolute certain that this is the compound and not a false positive. I will go over the pattern that this system includes, but I think the second, the most important, is that with the pattern that reduce the noise, we had a better detection limit, and we can improve any spectral technology by a factor of 5, and that gives us the ability to measure all the compounds needed to be measured by this rule in ppb level or sub-ppb levels. Another feature that we want to give our client is the source location, and that we do as I demonstrated the last conference with back triangulation. And again, we find the source and we give it in very easy way to understand. On Google Map, the brighter the color, what you see in the circle, meaning the higher possibility that the emission comes from that area. We'll skip this one and this one. So now we actually starting today's presentation, and we discussed the recent changes in the US legislation. Everybody knows the Federal Registry, what we call the Benzene Rule. And then California wrote AB 1647, that was every county write his own rules, like the San Francisco, the Bay Area wrote Rule 1115, Regulation 1215. And then it says that every refinery must measure actually almost everything that emits. In the Bay Area, it's the BTEX and supposed to be the alkanes, once we put at the end ammonia, SO2, and other organic compounds, and report to the public on real-time basis. And the South Coast rule is called Rule 1180, and it's a little bit got more points and more clear what to do. And actually the list of the contaminated is even greater than what you need to monitor by the Bay Area, and also the guidance document. But in the end, we need to measure the compounds and we need to report the public after quality assurance on real-time basis. So the first question that people should know, who should monitor? So in California, at least when the rule was written, there was 15 refineries. And most of the regulation, and that includes 1180, said that you must go on this program if you are above 40 barrels per day. That raises the first question. Is there a real connection between the size of the refinery and its emissions? I'm not sure about it, because sometimes large refineries invest a lot of money and people finding the emission and fixing them, and that could be that a small refinery doesn't have the money to do it and emit more. So large refinery doesn't necessarily mean large emission, and I can tell you from reviewing the data from the big refineries, at least in the South Coast, and that those refineries surprisingly operate very well. Surprisingly to me, at least. So the second question after we answer who should monitor will be which chemical should be monitored. And in 2017, the Office of Environment, Health, Hazards Assessment, together with EPA California, wrote this document, and its analysis of the chemical emission that can be potentially emitted from the refinery. It's identified 188 chemicals, and he give for most of them a threshold or recommended threshold. It's acute for 1 hour average, 8-hour averages, and 1 year averages. And this is important because the whole program meant to give a notification to the people when those limits are exceeding. So this is the list that needed to be monitored by Rule 1180. We got a few criteria: pollutant like the SOx and NOx. We got volatile organic compounds that we discuss later on, but among them the formaldehyde, acetaldehyde, the BTEX, styrene, and we get HCl, HF, ammonia, etc. If I will go back to remind us the purpose of the law, so because of the Fenceline monitoring system must alert to the public when there is exceedances, it is clear that the measurement sensitivity, or what we call method detection limit, must be less than the alerting threshold. And unfortunately, it's not the case with all the refineries today. So I look at a wide list, or big list of contaminant, and what you can see is the threshold, the 1 hour acute threshold, the 8 hour, and the ALIA chronic threshold. Again, keep in mind the detection limit must be below the 1 hour acute OIA threshold. And what you can see here that at least using Atmosfir Fenceline system, you can use just one instrument and you can go below the threshold for almost all the compound, except two that we measure in different technique. We discuss it, the H2S and the black carbon. But how we measure total VOC, non-methane hydrocarbons? We know how to measure them in chimneys on stack. We got a method to do it with 25. We measure with FID the total VOC. We take out the methane, and we know what is total VOC. But there is no open pathway to do it, or at least not one that everybody agrees on. So what are the total VOC non-methane in refineries, and how we should measure them? So I look at the document, the OIA document, and I sum up all the emission going out of the refinery as reported to the regulator. And what we found out that benzene is less than 1% of the total VOC from emission from refineries and actually petrochemical industry. The second, if we're going to use the BTEX as a surrogate for the total VOC, we can see that the BTEX are just 6% of the total emissions. So it's not that good as well. Other people suggested that let's sum all the compound, the BTEX and the styrene and the formaldehyde, let's sum all of them together. That will be a good surrogate for the VOCs, but actually it's less than 10% of the emission if you look at it. But if you look at the total alkane, meaning the octane, the hexane, and you measure those, they represent more than 60% of the total emission from refinery. And this is based on the reported data, the refinery themselves reported data. So people can say this is reported data, maybe it's not true. So let's look at real data from refinery, and what we see here, I think it's 2-week average of measurement on the fence line of a refinery. And what we see on the picture on the left, that benzene, at least in California, is usually below the measurement sensitivity. Rarely you find any hits of benzene above 1 ppb. And when there is a vent that there is emission, usually the concentration go in tenths of ppb. like if you forgot to close a valve or you got a leaking tank. If you look at the total alkane, no matter where you go in the refinery, you find concentration between 50 to 500. And when there is a malfunction in the equipment or human error, then the concentration go up to ppm's level or 10 of ppm's level. In other words, and in some countries, people think that benzene is a good surrogate for VOC emission. So the last two slides maybe prove that it's not. So if I succeed in convincing you that total alkane is the main emission going out of refinery, so how we measure that? And again, we don't need to invent the wheel. Every compound that got a CH bond absorb light in the CH stretch that you can see in the spectral signature in the picture on the right. But if you're going to look at the shape, there is no distinguish difference between the shapes. That's why we cannot tell the difference between butane, hexane, and octane. And we can measure them just as a composition. And again, how to do it? There is an EPA procedure actually done by our team and accepted by the EPA as a document. And what you see here is a screenshot of our system. Red is the composition or the reference composition of two alkanes, and in blue is what we are measuring in the field. So now we know that we did the composition correctly. But what you see in the second red circle is the molecular weight of the composition. If you're going to look at the data going out of the refinery, the report total VOCs in ppb. What is total VOC in ppb? It's meaningless. If you don't have the molecular weight, then you cannot do mass balance, then you cannot do fluxes, and actually telling ppb in total alkane is meaningless. So I think every time people report total alkanes or total VOC or to report any mixture, it must come with equivalent molecular weight. And again, there is a procedure that says how to do it. And unfortunately, or not all the refinery work like that. We talk a little bit about another two compounds. One is the H2S, the rotten eggs compound. And again, the urea threshold is 42 microgram per cubic meter. If we will translate it, we are talking about 30 ppb. But there is no open path technology that can measure H2S below the desired detection limit, below 30 ppb or below 20 ppb. If you look at the FTIR, if you are talking about the best FTIR, it can go down to 200 ppb, some of them 1 ppm. And the tunable dyed laser, I never saw someone go as low as 30. Some of them claim that they can go to 30. But again, keep in mind that the other threshold for H2S is just a few ppb, like 5 or 7 ppb. And the threshold by OEA is 30 ppb. So again, using an open path technique for that will be meaningless. The other compound that we're talking about is black carbon. And black carbon is something like a soot or particulate. And again, there is no official technique that can measure it with open path capabilities, at least not for today. And we go to a black carbon analyzer or point monitor for that. And what is a point monitor? We extract air through a pipe into the analyzers. Each analyzer works in a slightly different way, and we give you the result just for one compound at one point. So our installation for Rule 1180 looks like that we can see at that movie. Okay. So what we've got is some kind of a cabinet or a trailer that equipped with OpenPath FTIR that stays on auto positioner penalty, so we can shoot the beam to two direction or three direction. The regulator thought that it was they're thinking that UV DOS maybe will have a better detection limit for BTEX, and that's why everybody put also a UV DOS. And we will look at the data and we will see that it's not necessarily true. We talk about the H2S analyzer and the black carbon analyzer, and each station also equipped with meteorological data. Let me continue. On the other side of the cabinet, we've got what we call retro tower. It's either a retro reflector or transmitter. Each refinery was surrounded by this optical fence. And the height of the cabinet was something between 2 to 3 meters, that it will not be blocked by people or by trucks. And the height of the retroreflector tower, at least the regulator wanted it to be in the height of the tanks, meaning around 10 meters when there are tanks, slightly lower when we are talking about processing. What you see here is our system, and actually the emission most of the time, or some of the time, comes out of the refinery. The system can identify the compound and can tell you where is the source. If it's coming from your area, you can go and fix it. And if it's not due to blame, then you can tell, yes, there is emission, but it's not coming from. Let's continue. So let's talk about the implementation of the rule. And what we see on the left is a screenshot of the South Coast website for the implementation of this rule. So the first thing, despite delay in time, all refineries required by Rule 1180 implemented sampling fence line monitoring system and website available to the public and the regulator. So the date was the 1st of January, slight delayed. By Mars, everybody were there. So what we get, if we need to do it, it's possible. All the 7 refineries did it. And that gives the public for the first time the ability to see or to get information about the pollutant on the borders of the refineries, what's going out of them, or what's going into the refineries, actually what is in the borders. We are talking about huge amount of data. We are talking over 30 million reported result every quarter to the public. And the big question in how we do a quality assurance for 30 million points, we cannot rely on humans for that. No human or no humans can do quality assurance for 30 million data. That's why I think it's important to automate the quality assurance, as you're going to see in the next few slides. All the 18 compounds that needed to be monitored by the rule had been reported by some of the, at least by some of the refineries. The good news, or more good news, is 99% of the time there were no exceeding of over the threshold, meaning that all reported concentration were lower than the threshold values. And when there is exceeding, the system alerted to the public on real time through the website or to their mail, and tell that there is exceedance and explain about the material and what is the risk to the public. So overall, it's a job well done, but we want to improve. We want to go to the best. And I think what was fascinating, at least for me, and the implementation of the South Coast Rule, is that for the first time, dozens of systems from a variety of manufacturer and service providers, FTIR, UV DOS, installed in the same area at the same time. So at the first time, we can see what are the capabilities of those technologies. And we are talking about 5 UV DOS provider, including the UCLA UV DOS, 4 different FTIR manufacturer, 4 different service integration, and 2 manufacturer of H2S and 2 manufacturer of black carbon. Altogether, at the 7 refineries, we are talking about 66 paths that were measured in the last year, and 30 point monitors for H2S and black carbon. Each one of the refineries had its own report into the public website. And I took a look at those websites and tried to summarize into the table that you see below. So in terms of time resolution reported to the public, everybody had the 1 hour concentration. Some of them had 5 minutes, some of them had 10 minutes also. And the rule actually said that you should do 5 minutes, 1 hour, 8 hours, and 24 hours averages. And that, at least, that's what we did for our client, is number 7. History and availability of the data. So all the refineries give you the ability to see the last 48 hours on real time. Some of them give you the ability to see all the data. And again, there is no uniformity in that. In terms of the quarterly report, each refinery needs to issue a quarterly report and publish to the public. So most of the refineries did that. Some of them had issued just 1 report and not the 3 that needed by today. And some of them just reported a draft. In terms of staying with the rule that the metal detection limit is below the threshold, 2 out of the 7 claims that they can do it. The rest of them got problems, especially with acrolein, that is very dangerous compound in very low threshold. I think it's 1.1 if I remember correctly. All of them give to the public learning resources and subscribe to notification. So in conclusion, there is no uniformity in the option to access history and time resolution. Not all the refineries have MDL below the threshold. There is no uniformity in the threshold for some of the pollutant. At least for acrolein, some of them claim that it's 1.1, some of them claim there is no, and some of them claim that it's 30. Same story goes with the total alkane, etc. All websites include learning center and option to receive alert. There is no uniformity in the method of measuring TVOC, and that is not good because we cannot compare or have a meaningful data if not everybody do the same. I look at the data completeness, accuracy, the precision that was reported in the quarterly report, and I will say again, All the data that you see in this presentation is public domain. Everybody can download it. It's not my thought, it's not my invention. Everything you can download from the refinery's website. So what we see in the last 3 quarters, that most of the reported data completeness of most of the system stand with completeness above 90%. There are here and there a few problems that this path or that path was just 70%, but overall the majority stand in the 90% availability. The reported data accuracy that was checked at least once every quarter was below 30%, and the precision was below 20%. We talk about the importance of the detection limit, and at least for the FTIR, there is an official method that says how you need to measure the detection limit. And the minimum detection limit, as written in EPA TO 16, is the minimum concentration of a compound that can be detected by an instrument with a given statistical probability. Usually, the detection limit is given 3 times the standard deviation of the noise of the system. But there's a lot about how the procedure should be done. But I think the most importantly, that it should be done exactly in the same manner that we measure or that we'll use in the field. That's why, at least with Atmosfir Fenceline system, we are measuring with every minute the detection limit of all the compound, and we report the data based on the official measurement. I see at least a few of those that actually stop the measurement 1 day of 3 or 1 day a month or quarter, aim it to just one target, to just one retroreflector, and do a series of 16 single beam spectra. This is not the way that it's working on the field, and that can bias the results. That is also important that you will choose a good instrumentation that stay below the detection limit, because in the public comments of or in the answer of to the public comments by South Coast, they said that if you fail to measure below the threshold, then you need to say how you can improve, and if it's needed, you should change the instrumentation. And they gave a time limit of 6 months to stand in the detection limit. I see that maybe the time was extended due to the COVID pandemic, but again, it will be over, at least in Israel. Everybody is now at the vaccine, and I see that in United States maybe in a couple of months. So life will be back to normal, I hope. And then we will see what South Coast gonna do with that. But again, keep in mind that if you need to monitor, choose an instrument that can stand with all the threshold that you need to measure, today threshold, and maybe look for the future as well. I took all the data from the reported quarterly report from all the vendor. What you see, it's Atmosfir Fenceline system, and I will not tell the name of the others, but let's call them vendor A, vendor B, vendor C, and vendor D. What you can see, it's the name of the compound and then the threshold, the 1 hour OEA threshold that you need to stand. With Atmosfir, I can give you the maximum detection limit. As you know, it's depend also on the path length and the atmospheric condition and the method and the goodness of the instrument and the goodness of your algorithm. So you can see our maximum detection limit. You can see our minimum detection limit. I also did an average. One thing unique about the Atmosfir Fenceline system that the old compound needed to be measured you see them just by the open path FTIR without the need of UV DOAS. Vendor A, vendor B, and vendor C, all the compound from 1,3 butadiene down to benzene done by an FTIR, and from benzene down to toluene was done by UV DOAS. And I think what you can see clearly is that despite what people may think, UV DOAS was found to be redundant to the fence line monitoring system if using a good FTIR system and algorithm. You can see that for most of the compound, or almost all the compounds, the atmosphere defense line system had the best detection limit, and that based on report that done by the vendors or the refineries after quality assurance. The second thing that we can see, that all the compounds can be measured below the threshold. At least 2 refineries said that they can measure everything, including the acroline below 1.1 ppb. I want to go back to the importance of quality assurance, because as you remember, we need to alert to the public on real-time basis. So when the system see high concentration, if it's valid, we need to report to the public and alert them. And I look at a few of the alerts, at least for the first quarter and the second quarter, and you can see a list of example on the table. And this is the second column is the 1 hour threshold, and in red is the reported to the public after quality assurance, and on the quarterly report, the concentration. And I look at those three, and it sounds not realistic, at least to my eye. Beside Atmosfir, I also run one of the biggest air measurement companies, at least in Israel, and I do all the measurement for the government of Israel. So I measure thousands of those samples, and never in my life I saw that high concentration. But those refineries send notification to the public that they were exceeding the limits. And I'm sure that it's not good for the company names. It's put the companies in risk of litigation. And sometimes we invest a lot of money and man-hour to find a leak that actually it's a false positive. And the question is, how can we be sure that what we alert or report is not a false positive? You know, it was my gut feeling that high concentration like that cannot be existed. So I took a few hours to do a research about it, and nowhere in the world that high concentration of formaldehyde in ambient air was exceeding 600 ppb. Actually, I never find a concentration higher than 80 ppb. So there is a good chance that this refinery or those refineries reported a false positive unnecessarily. With our defense line system, we don't, as I told you before, with every compound that we report, we give you a spectral fingerprint. And if you're talking about formaldehyde, what we see here is from our report, from our quarterly report, we say there is 4 ppb of formaldehyde, and you can see in red the reference spectra for 4 ppb of formaldehyde. Blue is what we are measuring in the field, and we are positive. If those refineries had the ability to look for the spectral signature, I almost certain that they will not report this data. Again, with our system, every number you can click on it and you will have a spectral validation. Sometimes we are wrong, but we can say in a matter of minutes that we did a wrong analysis and not wait and also report in the quarterly report problematic data. Let's continue look at the data that was reported by the refineries. So let's talk about this refinery. So what we can see in that table, it's the benzene that was measured by UV DOAS, and the detection limit was between 1 to 3.5 ppb, not better than the FTIR. And something unbelievable that was also reported to the public and still reported to the public is acrolein. Acrolein detection limit is 27 times higher than the OEA threshold. So meaning that the analyzer is meaningless for measuring acrolein. But even worse, if you look at the graph below, in red, you can see the line of the threshold. All the color are the different paths. Someone mistakenly can think that the acrolein are all the time exceeding the limit, something that it's not true. Again, the example of above 60, 100 ppb for formaldehyde that I suspect it at least false positive. Again, if you look at the benzene concentration, rarely there is a benzene hit above the detection limit. Let's move to another refinery. And this refinery is actually even more interesting, because in that refinery, we got two different equipment provider and two different service providers. So it's the same refinery, the same area. And what we can see in the picture that all the south and all the parts got ammonia, but on the north that it's a different provider, there's no even one ammonia hits. And if we look at the summarize that they published in quarter number 2, first of all, we can see that the acrolein, one found it a little bit, the other didn't find it at all, but it was 3 times the OEA threshold. The reported benzene was between 0.7 and 1 ppb detection limit. This service provider, it's theoretical detection limit. It's not based on measurement. Again, something even more shocking was that one of the service provider find all the compounds. Most of the time he find ammonia, and he find quite a lot of total VOC going out of refineries, which is logic. But the other service provider almost didn't find nothing, and also no VOC going out of the refineries. And this put the data in a question mark. As we see, ammonia 93% of the time, and the other service provider the same time, same area, didn't find even bromide of ammonia, and the same goes with the rest of the compounds. Again, this lead that automated quality assurance, real quality assurance should be implemented, and it's not that easy to do a spectroscopist analysis. Then I thought maybe I will take the data from a few refineries and combine them together with wind direction. So for the last, I think, quarter, or I think the compound that actually exceed most of the time is hydrogen sulfide. And when I analyzed the hydrogen sulfide, when the orange refinery had high concentration, the wind was blowing from the east. And when the pink one had high concentration, the wind was blowing with a north vector. And when the green, it was with a southerly wind. And then I said, let's look at the cut point or the back triangulation of those winds. And that maybe is the source. And what we see, it's not related to the refineries, it's actually in between the refineries. And because we got Google map or satellite map, we can look at the area and then you can see two yellow dots. And as we all know, yellow is sulfur. So I suspect this is the source of the H2S exceedant and not necessarily the refineries they report to the public. That leads us to the lessons and the recommendation. And I think with that, we will finish. So there are many potential sources that can affect concentration of different pollutants. We saw example of H2S, but we know that there's many potential for ammonia, for sure VOC and black carbon. Just to mention the trucks, the roads, the trains, and all the industrial areas surrounding. Therefore, it's recommended that the regulator and the refineries will acquire the ability to identify the different sources, at least to tell, yes, we had high concentration of H2S, but it's not coming from our facility based on triangulation of the wind. The second thing that I think we should improve that, or should understand that most of the emission from refinery, and this is based on the now measurement that we do, it's total VOCs or alkane, and not benzene and not BTEX and not some of the other compounds. Benzene, at least in the South Coast, is rarely found and reported above 1 to 3 ppb. At least if you take a good NFTIR and a good algorithm, then you don't need a UV DOS to stand with good detection limit. Automatic quality assurance, including spectral validation, should be used by refineries and the regulator to improve the supervision over 1 million data points, especially when we report the data to the public on real-time basis. Fenceline monitoring program can work. We saw that all the refinery did it in less than a year and reported data to the public more of 90% completeness. The list of contaminate monitors should be updated. I think every refinery should at least measure the same compound, and this is not the case if you go into California. The Bay Area got a different list, the South Coast got a different list, and again, inside the counties, some of the refineries got different lists. And I think the list can be extended. The FTIR technology at least can measure a lot of other gases, actually almost all the gases, including the greenhouse gases. And doing that, we will improve the safety and our knowledge about the emission. And it will not be additional cost. The system are already there. One thing that I would love to see is one website that presents the data from all the refineries with database available to the public, maybe with triangulation on something like that. Today, there is one website, but it's not a uniform database. So from that website, you can go to each one of the refineries, but not all the refineries share the same database. The website should have the ability to use the data from all sites to clearly present the pollution picture. The website should have the ability to semi-automatically validate the data from all sites. We don't want wrong reporting. With the full implementation of Rule 1180, I think that the people now near the refinery can sleep better. They got a reliable alert system in case of emergency. About the technology, I think that if you got an FTIR that can measure a compound and you got a UV dose that can measure compounds, at least for the FTIR you got an official method, so it's better to use an FTIR even just because of that. And I'm not a manufacturer, not of FTIR, not for UV dose. So it is recommended to define a uniform method for measuring total VOC. And today I think everybody or everyone do it slightly different. And there is an EPA protocol, and I think everybody should follow the same protocol. Otherwise, again, the result will be meaningless. It is recommended to define a uniform method for measuring sensitivity or procedure to how to do it to compare detection limit. And that leads us, I think, and this will be, again, a sales pitch from by me. What Atmosfir did is write a patent and algorithm, take the best software and the best hardware. And with that, we got online quality assurance for spectral validation. We give our client automatic tools for source location. We got unprecedented detection limit using just one instrument. We can measure all the compounds, including the total gains, and give the molecular weight of the composition that eliminate the need for UV dose. And we think that our software is very easy to use. And you can shoot me an email. I can give you a demo website. You can play with it, and you're going to see that in less than 1 hour, you are an expert on getting data from this system. And I think because it's not an analyzer, you should have 24/7 technical and scientific support in times that you are not sure that the data is clear. Okay. This is a few of the defense line installation, how it looks like. And at least Atmosfir Optics can give you the planning stage. We can execute. We did it in a few projects. We can do the quality assurance, and we can sell also just the software package to improve the data validation of what you reported. So no matter who is your instrument manufacturer or your service provider, if you want to improve your quality assurance and you want to eliminate reporting error, we can help you with that. And that technology is also good for other contamination investigations. Like it's the only technology that I know that can measure in real time. I mean, smell competence. We did project in water treatment, etc. We can measure fluxes, help with wise LDAR, flare combustion efficiency, etc. Before the webinar started, there was a jam session and that reminded me that in one of the conferences we wrote this theme song. And with that, I will finish.
I'm Stephen Lazar. I'm from Atmosfir Optics, and I am here to tell you that you have the right to real-time, remotely sensed emissions data that you can have 100% confidence is accurate and precise. So come on, everyone, sing with me. Get up, stand up. Stand up for your rights. Stand up, stand up. Don't give up the fight. Some people sometimes, you can't fool all the people all the time. Fence line system, real-time source location. Fence line system, real-time spectrum validation.
Okay, thank you very
So
much.
we'll definitely do that at the jam session. So all of you have that now on the webinar that you can access on the 4C page, so you can learn it ahead of time.
For those of you who were not on the webinar pre-call, we had a little spontaneous jam session. 4 of the people that were on the call just happened to have a guitar handy, and all took turns playing. Love it. I love it. I love it. There is a question, says, as EPA moves forward with reconsidering EMACT, RTR, and other rules, will EPA be looking to California rules?
I'm sure, hope so, but I'm not. I cannot speak on behalf of the EPA. Maybe you can answer this question.
I would just make a comment in that California being a little bit ahead of the curve, it tends to be looked at by other states and by the feds. And we expect the EPA to move in that direction. With the new administration in Washington, we've seen some very positive changes already that impact our industry. So we're not privy to exactly what the EPA is going to be doing, but we do expect them to use California as an example, and then we'll just see where we go from here. I know the community monitoring goals of this. The environmental justice goals of this new administration will eventually lead to community monitoring. When that'll actually occur is anybody's guess, but I think it would be, knowing that that's an inevitability, in addition to what Steve brought up on the last webinar of the recent advances in satellite imaging, which will make emissions more publicly available. Given both of those facts, I think it behooves everybody to be proactive and be protected ahead of time.
Yes, I'll certainly make a shameless plug for the 4C conference on August 18th to the 20th. The environmental justice will be certainly a topic. It's of great interest, I think, to everyone. Fenceline monitoring is also, it's here. The refineries have been doing it. The chemical companies have consent decrees that are being negotiated, which may also envision some fenceline monitoring. I believe the emerging issue of ethylene oxide will also drive some fenceline monitoring. So, fenceline monitoring is definitely, it's here to stay. It's directionally, it's where the thought leaders are going. And it's much more in line with the technology available today and the age of the digital transformation.
If I could also make another comment and clarification of what I said last in regards to community monitoring and what you've just said, Steve. With the technology available, fenceline monitoring is the best way to do community monitoring and to protect the community, because without that, there's really no way of knowing what facilities are emitting and how much from each facility and what the sources are. And beyond that, given those facilities, accurate and precise fence line monitoring gives those facilities the ability to actually correct the emissions problems in real time so that they don't lead to larger issues.
Yeah, most certainly fence line monitoring is here to stay, and what form that takes is something that, you know, we'll see. It may take different forms in different states. Different companies may decide upon different technologies. But one thing is for sure, if you're in the chemical refining industry anywhere in the world, you want to be paying attention to this issue of fence line monitoring, and you want to be aware of the fence line monitoring technologies and know which one is most appropriate for your facility. And that's not going to change. That's going to become a bigger and bigger issue as every year progresses. And the number of satellites going up, as you mentioned, Steve. The more satellites means the more frequent you have concentrations around every industrial property. And certainly that information will be available to the public. And there are a number of technologies out there already that are available to the public. So, you know, at some point, the public's going to have some of those monitoring and sensing devices, you know, in their backyard. And as you know, that becomes more prevalent in addition to the satellites, it just becomes imperative that industry has visibility to what's going across their fence line. And this technology certainly delivers that information in abundance. So thank you very, very much, Gilad. Thank you, Steve, for your musical contributions and your insight. And thank you to everyone. Oh, there's one more question. Says, by community monitoring, do you mean fence line monitoring? And
yeah, I think I clarified that.
Okay, yeah,
I should have led to that in my original comment.
Yes, there's
so we're very much looking forward. I just want to say on behalf of Atmosfir, we're very much looking forward to participating in the 4C conference, and thank you very much, Steve, for these opportunities to give these important technical webinars. And we'll have more information for everyone at the conference, and look forward to meeting you all personally.
Yes, always wonderful, especially in this COVID environment, the idea of getting to see people again and meet people and collaborate and share time and space. That's what 4C is all about, and I'm super excited for that. And thank you, Gilad. Thank you, Steve, for your time today and your contributions.
Thank you.
Okay, with that, we'll conclude the webinar.
Okay, everybody be safe.
Take care.